Welcome back to another Super Magnet Man video. One of the topics that we get asked about all the time is Halbach. Halbach arrays are a very important part of magnet geometries and helping us better understand how to put fields together. But interestingly enough, it seems like everybody that hears the word Halbach thinks this is some special magnet that is different, and it's the answer to all problems because it makes the magnetic field stronger and it weakens one side. And many times that's the right thing to do, but not always. So what I wanted to do is take a minute and help us better understand the real use of a Halbach. So I've got a Halbach made out of N52 half-inch cubes. This is 5 magnets arrayed in the Halbach. You can find this design on the Wikipedia, which talks about this. And I've got these 5, and we're going to take a look at the numbers on this in just a second. To compare it, I was wondering what would happen if I took the same half-inch cubes and arranged them all in the same direction. So let's take a look at what the Gauss readings actually tell us. To take a look at this, we took our Gauss meter and we got us some readings above both sets of magnets. So if you look at the surface of the magnet, on this bottom one, all of the magnets should be essentially the same, and when you put them together, it's going to change a little bit. And we see that the ends are 5200, 4900, and in the middle we get 47 to 4900, so it's just a tiny bit weaker in the middle. Overall, this gives us an average of 4,880 Gauss. And of course, those readings are a little bit, you could probably just say it's an average of 48 or 4,900. Either way. Now let's look at what we got on the surface of the Halbach. And this is where Halbach really has its advantage. This end magnet and this end magnet are both about 100 Gauss because you're measuring perpendicular to the flux. The flux is actually going this way and it's going this way. So you're not really measuring that. It's like measuring parallel to it, so it's not getting anything to it. You look at this one though, and this magnet above it was 7,300 Gauss. That's way higher than we get. The single magnetic field is about 5,200 Gauss, but this one jumps it to 7,300. Now there's a transition magnet. Again, we're measuring parallel to the flow of magnetism, so we don't really measure very much. We're only getting 500, and if you move back and forth a little bit, you switch between north and south. So we get 7,400 over this magnet, just a little bit higher. Could be just depending on where you're measuring, but sometimes magnets will do that. It's just a little bit of difference. And when we average this, we get 4,160 Gauss across the surface. Now, if we take this magnet and go a ½ inch above it, this set of readings is 1/2 inch above the surface of the magnet. You see that we're down to 800, but then we're a solid 1,000 Gauss across the center and 800 on the end. When we take the Halbach and we are 1/2 inch above it, we get 200, 1,020, 1,000, and 300. What's happening with the Halbach is since the North Pole is here and this is the South Pole, we've got a little space in between it. The magnetic field lines go like this. So your north and south are connecting. If you look at this one, this is being treated as if it's one large magnet, and the magnetic flux lines would look like this. So you're not seeing a big difference. On the underside of this magnet, it measures about 3,000 Gauss, but on the bottom of this one, it would match exactly what we see above. It would average about 5,000 Gauss all across the bottom. So if you're needing to move the magnetic field to the other side, what you're really doing is taking the flux from 3 magnets and forcing it into 2. Gives us a very strong field above these 2, but much weaker below the others. Now, this has some specific applications. When you look at this in the business world or the commercial world, and we're trying to design uses for this, if you are working very close to the surface of the magnets, like in a motor or an alternator design, you can see that having these high values is very important. That can get you a lot more power out of an electric motor or a lot more power out of an electric generator, alternator type application. And we're going to take a look at some magnets that are oriented this way. As we look at this, we have had a couple of magnets made that are Halbach assemblies. We've had the factory make these for us to give you an idea of what we have this one has 2 poles, and it's about 5,200 Gauss on the center. These are small magnets, but each magnet is rolling the field around. You can see that better with this, how you can see that 1/2 is one polarity, and you see this sharp dividing line across the middle. That lets us see where the poles are separated. This one, the high intensity field, is here and here. And you can see how each of these magnets, because they're angle magnetized, helps it bend the flux around. We'll look at that in just a second as a drawing to show you how to do this. But this magnet is made of magnets that are about a 1/2 inch thick. They're arc segments all glued together with special magnetization to roll the field to these 2 high intensity points. Now we have another one that we made that is a little larger. You can see it's much wider. If we look at these 2 together, you can see the width is twice the width, and you can see that the magnets are twice as thick. The outside diameter is a little bigger, and so this is making us a very special magnet, and we reach about 7,200 to 7,500 Gauss on the poles here. And you can see that with our viewing film, once again, seeing where the flux is going and how each of the magnets are rolling around the flux. That's what these little lines are showing you, is that flux just keeps turning because of the angle that they are magnetized at. So these are 2 that we have as a standard product on our website, but we have another one that we made for research purposes years ago, and this one is it also uses 2 things. Number one, while it is a Halbach array, and you can see the arrow showing you the angle that it's been magnetized, we took advantage of another geometry modification. What we did is used pyramid magnets. So it's going from a 2-inch pyramid to about a 9mm top, and each magnet is 2 inches thick. And each of these are angle magnetized. What this does for us is gives us an incredibly powerful field on the inside. We'll talk about that in a second. Again, you can easily see the sharp dividing line showing us where the poles are. That line that you see is perpendicular to the maximum line of flux. The flux line is here where we see the 2 poles. So let's take a look on the board and see how this magnet is made. To take a look at this Halbach in a little bit more detail, I mentioned to you that we have angle magnetized. And what does angle magnetization mean? The reason that I say angle magnetization is your normal neodymium material is anisotropic. And anisotropic means we can't change the magnetic domains after it has been magnetized. So all of the domains are established at the very beginning. It's in the very first step of making a magnet, it has its domains established. So how do we take something like this and magnetize it at a 45-degree angle? Back to geometry. What we do is cut the magnet. We will take a magnet, if we want 45-degree magnetization, we will cut the magnet like this. This will give us whatever angle that we want. Now what it also does is it creates wasted material here, here, and back here. You can see we're losing some material, but we need this particular design so that we can increase the flux in this path. And you can notice that with this Halbach, I've got this written up here as 1.2 Tesla. Across that entire gap, all the way across, we average about 1.2 Tesla from one side to the other. We can add some other magnets. It reduces the gap in the middle, but if we use some stacking magnets, we can focus that field to about 1.6 Tesla, which is an extremely powerful magnetic field, certainly for a permanent magnet. If we're making this magnet, we're trying to do that. We use, again, the same square block of material, but now with the flux going this way, we will cut it like this. And that gives us magnetic flux that's parallel to the base, which are these end pieces here. Now, one of the things about this material is while we cannot change the domains, we could change the polarity. We can take the same design, and where this might have north on the top and south on the bottom, we can remagnetize this so that it comes out with south on the top and north on the bottom. That's not a problem. It's a problem to change that angle or to go perpendicular to it or anything like that. So this is a key part that helps us determine the cost factors in making a Halbach. First of all, they're extremely powerful. All pieces are repelling each other. and they're going to try and bounce apart. And to do so, you have to make a special apparatus. And many times you may use a hydraulic cylinder to force the pieces together to get them inside their fixture so that you can have this. All of this adds to the cost. And so this is one of the things to keep in mind when you're looking at using a Halbach. At Super Magnet Man, we like to help our customers determine, is a Halbach the right solution for your application? Sometimes all you may need is a standard magnet. At other times, if you really need the high intensity fields, we look at the Halbach as an option to see how much fields you really need. If you need 7, 8, 9, 10,000 Gauss, then a Halbach may be the best option for you. If you're making an electric motor or an alternator generator, you might want to use the Halbach because that is going to give you higher flux intensity than you're going to get with a standard magnet. This is why many of the motors today that are coming out in the automotive industry are coming out as Halbach motors because they know they can get more power out of the same weight motor. So these are many considerations, and at Super Magnet Man, we would love to talk with you about your application and help you develop the right solution using the right magnet geometry to solve your problem. So whenever you have a problem, give us a call and Super Magnet Man will help you.